everyone. 11 Thursday, October 5th, at around 6 p.m. heading out from work, and today my mind is back on pandas. So it seems that on almost every project I do in Python these days, there's this threshold, this vibrating edge, that if I push what I'm trying to do with data even just a hair further than I am, such as the use of a second or a third data source in producing some deliverable, the question always arises, should I be using the Pandas library, which effectively gives you SQL-like capabilities in what feels like native Python. So truly it is native Python. There's optimizations underneath, as there are with everything that is based on NumPy. NumPy is a n-dimensional data array library compiled in C, written and compiled for really fast number crunching, the heir apparent of the Fortran programming language in the Python world. And oh my god, there's so many sub-stories here. It's a two-edged sword. It gives you such great speed on fast CPUs, but because it uses the C library APIs in Python, it uses the global interpreter lock, or the much maligned GIL, and does not take advantage of multiple processors in same said fast machines. So this is one of the giant jokes in data science right now. The most user-friendly and accessible tools, especially once you look past R and towards things that really integrate well with the real world and can control processes, tie into scheduling and web servers, all roads lead to Python. It might not be R, but it can do a lot of stuff. And a lot of the experimental platforms for data manipulation, like Jupyter Notebook, are tooled towards Python. So anyway, because of all that, every time you do a project with data that calls for doing stuff that you would only just be able to do if this were SQL and you were in a relational database environment, and a lot of times you end up installing or using a cloud SQL server in some form or another, and then using a package like SQL Alchemy. You can tell by my face how much how I feel about this whole approach. But if you're doing these lightweight transient things where your applications really are running in a greatly stateless way, they have no memory when they start, they have no memory when they're done. Occasionally you'll fill caches that expire so that the data is fresh under conditions of your determining, without creating local file bloat. Some local file bloat's okay, even in what they call webheads, or the scheduling equivalent of really lightweight middleware that shouldn't be accumulating all this data cruft. So you use pandas. You hit different data sources, APIs, however you do it. Search Console and Google Analytics are two very frequent ones for me. And sometimes you'll get a table whose equivalent to a primary key, whole sub-discussion there, but basically to tell the uniqueness of every row in your table, every row should have at least one column with a unique value, and if it doesn't, you can create unique constraints from more than one column. So very frequently for URL performance tracking, for SEO monitoring stuff, you'll have the date that you perform the test. That date might also stand for a week or a month, so you might have to record whether it's a weekly or a monthly time period, or have start and end dates. There's so many ways to slice it, but when you're trying to do it efficiently, you might just use weekly time intervals in that particular table. So all you have to do is give it a start date and a URL and a keyword, and then the other columns are for tracking the metrics like, position, impressions, clicks. That kind of stuff comes from Google Search Console. But you might have one table that has per URL per keyword, and another table doesn't have keyword data, i.e. Google Analytics typically. So its table has per URL. So your unique constraint in one case has an extra column in it than the other. So your number of rows that come back is by definition different, even though you're getting reports on the same set of URLs, because the same URL will occur a second, a third, or the fourth time in the table that's storing the per URL per keyword performance, and the date could be the third column of the unique constraint, at least in the data collection table, because there's also reporting tables that hold aggregate, and summary calculations, roll-ups, whatever terminology you want to use, to looking at your original data pull and analyzing it and storing the result of your analysis somewhere else. And so, as you can imagine, the data involved here that you're pulling, storing, could get mighty weighty. And in fact, it does. And a lot of people end up using services like Amazon S3 as a data bucket, or maybe setting up a local Redis server if you don't want to use the cloud. Even a Postgres database could accommodate this, because, contrary to popular belief, you can get the best of both worlds of NoSQL and relational database management systems, RDBMS, the two opposing worlds of data right now, with Postgres. It seems that a lot of the things about the NoSQL database, and a whole other sub-discussion here, has to do with sysadmin issues, how it handles sharding, and whether it's acidic or basic, and all these, distributed database transaction atomicness, things to keep mission critical, must not be corrupted data from being corrupted, spacing out how it can resolve and get the same everywhere, or whether you even need the whole database everywhere. There's so many ways this stuff gets sliced and diced, which is why as soon as your project involves a database or even a second server, I could go on with these things. It's like adding another dimension to a report. The number of rows coming back doubles, and now the amount of overhead mentally more than doubles, it quadruples. So multiple data sources, you're bringing them back, the number of rows on the left doesn't match the number of rows on the right. You got to decide whether you want to summarize or expand out. These are like left inner and left outer join issues that those familiar with SQL deal with all the time. And so you can do all this stuff given enough memory to load the data sets you're doing this to, do the calculations, commit it back to whatever. You can load the data sources from wherever. Everything maps pretty well to the common Python data objects, the default core stuff. Sometimes, though, you want to do SQL-like stuff, and you don't want to use just the default native Python data objects. You want to use things that more resemble the n-dimension array of NumPy, and has the speed and performance there, and lets you do joins, unions, group bys, and distincts, and all these stuff that you're familiar with from SQL, but without necessarily the SQL language. There's lots of ways to do it. There's Pandas SQL. I actually played around with those a little. I've got some code using that stuff in deployment. But I do find that native pandas, which is just a Python API that doesn't require embedding raw SQL, but it has roughly the same amount of expressiveness for doing this sort of stuff. So one of the common things is, as soon as you're going from more rows to less rows, how are you doing that? They're going to be grouping by or distincting on a single value or two values perhaps. But then those other things, what does it plug in that cell? Should it choose the average, the sum, the median? And I'm drawing spark lines, so it's going to get really interesting as I create an array of everything from somewhere else. I'm going to actually have to nest on every row a Python function within a Pandas data transformation, assuming that all this stuff is optimized. I see examples on the internet for this sort of stuff, so it should not be an issue to sort of blend together the expressiveness and data requests of SQL with the power of Python functions and programming in line, so that you can do something fancy like create the code required for spark lines as a result of Pandas query. Anyway, that is what I'm hoping, and that is what I am going to be putting most of my work towards tomorrow. And you know, this is like a lot of success assured moments. I did a lot of tests today. I built a lot of the functional building pieces of doing a larger project, and tomorrow I hit it hard and hopefully get a significant portion of the SEO recommendation tracking system operational. Lightweight Python middleware, flies on automatic, and you can just keep layering on the reports, and you just follow a link to see how your endeavors are doing from the time you launched it, even with directional data samples going weeks back before that, so you can see whether your recommendations were likely to be what had the impact or not, and it can tie in with other systems. I checked the code on the pages out there. So the sky's the limit, and who pays for all this? Well, aside from burden cost of employee, Uncle Google, because the only data structures I'm leaning on are those that are free or we're already paying for under whatever G Suite deals, you know, you get when you base your office infrastructure on Google. So anyway, a lot of good stuff going on. It's getting exciting, and this is certainly more aligned with that data master stuff I want to talk about. And I wind up there. Thanks for joining me. Hope to talk to you again soon, and don't forget to subscribe.